Hello everyone, my name is David Flores, also known as NetPanda, and today I will be talking about the use of the Elasticsearch inside GNS3 topology to process network syslog data. This is my first video, so please bear with me. For those of you who don't know about the Elasticsearch, I'm going to refer them to the Elasticsearch website, and there's a summary of a quick definition of the ELK stack. So basically the ELK is the acronym for three open source projects, which are Elasticsearch, Logstash and Kibana. Elasticsearch is a search and analytics engine, and Logstash is a server-side data processing pipeline that ingests data from multiple sources simultaneously, transforms it, and then sends it to a stash like Elasticsearch. Kibana lets users visualize the data with charts and graphs in Elasticsearch. So I will be using this stack to handle network devices log data. And the goal of this demo is to show you how to configure the Logstash pipeline. The Logstash pipeline is, well, the syslog server per se. It's going to listen to the syslog events, it's going to parse them, transform them, and send that data in form of JSON documents into Elasticsearch, which are going to be stored. We can visualize that data with Kibana, okay, which is a web-based visualization tool. Okay. The topology is composed of IOSV layer 3 routers connected between each other. The configuration is already set, and it has interface IP addressing, OSPF configuration, some basic SSH setup, archive setup to log config commands, and of course the syslog server information. Here I am in the console of one of the routers, and I'm going to show you really quick a little bit about these configuration settings. So, for example, you can see here the archive part, which is really important for a specific visualization that I'm going to show you next about network config audit, if you want to audit the configuration commands that are sent into to your device. So you can see now some user information as well, some interfaces with their IP addressing configured, some OSPF configuration with local GNS3 details, and well, and here is the syslog part. We're going to send the data over to this IP address, which is the Logstash instance. We're going to use UDP as the transport protocol, and the port is going to be 5014. Okay. This is the management network of the devices, or the network devices, and is that 10.70.70/24 network. Logstash has a leg into that network and also has a leg to the ELK stack. And the ELK stack is actually configured on 192.168 network /24. The Kibana also has a connection to the cloud interface object and is exposing the port 5601 in order for our computer to reach the Kibana web application. Okay, now let's talk about this part of the network, the Elasticsearch, and the configuration that needs to happen. Even though the lab is already up and running, I will show you the template setup and the specific node configuration that you need to take into account while building this topology. The Elastic instances are Docker containers using official images from the Elastic Docker repo. This is one of the factors that makes the lab portable with reduced complexity. Well, except the Logstash one, because it needed to correctly specify the user when building the image, so I created a wrapper image around it. Okay, first let's dig into the templates. Let's go to the Docker containers, and here are the templates. You can see that it's a standard container configuration inside GNS3, and the image name, well, is pointing to the official Docker repo. There's an environment variable over here that specifies that is going to be working in a standalone development mode, the Elasticsearch node. So that's why the discovery type is equal to single node. And all these containers have an extra volume pointing to their data or configuration directories. Okay, that's for persistency. So even if you shut down the lab and bring it back up, that information is still there. You can see that Kibana is actually simpler. The configuration, there's nothing more to it. All these containers have 2 or more adapters. That's, well, for basically to connect them into different parts of the network if you need to. The Logstash one, you can see that is pointing to my repo, and also has this environment variable called config reload automatic set to true. Okay, so what does this mean? Logstash has this concept of pipelines and configuration pipelines. The pipelines are how a data stream is going to be processed. It's going to be listened, it's going to be processed, and it's going to be sent, basically. And the configuration pipeline is just a file that gives the instructions of how it's going to do that. When you set this environment variable to true, it's going to apply the configuration on the fly, and you don't need to reload the process because usually by default it's set to false. And what you normally do is that you apply some configuration changes into your pipeline and reload or restart the service. Okay, with this we don't need to, so it's really important for this to have to be set to true. Okay, it's really good for debugging purposes. Okay, so great. Now let's jump into the containers configuration themselves. Okay, you see that they inherit the configuration from their templates, but let's look at the network interfaces part. Now, the Docker images are based on CentOS 7, and the network configuration can be set like how you would normally do on these hosts. You can see that the interface Ethernet series pointing to the Elasticsearch network, the 192.168, and the other leg is pointing to the network, the management network, well, the management interfaces of the network devices. Okay. An important note here is that depending if you define the gateway, okay, on the interface, it will create a default route for it as well. So keep this in mind when configuring the interface. Especially, well, a good example is the Kibana one. I had to configure the gateway over to the cloud object and not to the Elk stack. Is not that important, but over here was really important. So my computer could reach the Kibana application without issues. Okay, and setting up the configuration that way with a gateway or without a gateway. It's really important, and well, you as a network engineer should know the value of it, because you don't want to modify routes inside your containers. You don't want to add more packets into the containers to add the capability. So it's important for you to know that fact. Now, let me jump back again to the configuration here in Logstash. Now, also, besides the network configuration of the interfaces, it's important to note to have some host file configuration. And why is that? At least the Elasticsearch one. Logstash and Kibana, by default, when they turn up the services, they're going to try to contact whatever Elasticsearch server cluster you have defined in either the configuration file or environment variables. By default, it's going to use the name Elasticsearch. So if you put the Elasticsearch name as a host file and you point that, it's going to work. It's going to start the containers without any issues, and that's really important. Okay, at least for labbing purposes. Of course, if you have a custom setup and you want to actually try this as an environment that you want to actually deploy in production, then be my guest and modify the parameters as you see fit. Okay, with the configuration set, you can start the containers. Well, of course, I already have them up and running, but I will show you what log entries you should be looking for to verify that the services are up and running. Let's start with Logstash. Okay, So, well, basically, all this console, all the logs of the devices, you can see them when you connect them through the console. Okay. So Logstash. Here is Logstash. Okay. So Logstash is pretty simple. You should look for at least this one. They successfully started the Logstash API endpoint. Okay. There's some more stuff here that is really important as well, but that's the main thing, that the server is up and running. Okay. And oh yeah, and sorry, and this one, that the server is up and running. At least for the port that you want to. By default, it's going to use the bits port, which is 5044. Okay. We have that by default, so you can see that there's no configuration here yet. Now on Kibana, you should look for, well, basically this guy, that the server is up and running. Okay, and you can see that the port is actually 5601. This is the port that we're going to use for the web application, to log into the web application. On Elasticsearch, well, there's a lot of logs, but the one that you should be looking for is this one. That the cluster health status changed from red to green or yellow to green. Doesn't matter too much, but at least it has to be green. That's the end goal. Okay, I have a machine over here next to Metro. Okay, I'm going to get basic Elasticsearch information, so I can do a curl. Okay. Oh yeah, by the way, this Metro machine is a custom Docker image that I have with multiple network tools out there. If you want to check it out, feel free. It's in the same repo as the Logstash one. Okay, so yeah, it seems that the Elasticsearch server is already up and running. It's a Docker cluster kind of thing. That's default configuration, and here I'm running the Elastic Stack on version 7.4.2. Okay, that's basically it. That's great. That's good news. Now let's start Kibana web application and see what we can find. Okay. Let me open over here. So I'm going to connect to the Kibana host. It's GNS3 _ Kibana and 65601. Okay. The application is loading. Exciting stuff. Okay, so this is the welcome banner. Welcome to Kibana, blah blah blah. Explore my own, and here we are. We are in the homepage of Kibana. There's a lot of tutorials over here. There's a lot of getting started with CSV information, some JSON, some log files, some CSV, you name it. They have solutions for APM logging, which is the one that we're going to look, and some metrics, and also on security. So I strongly suggest you to take a look at this and see if it fits your needs. Okay, now Kibana has a lot of dashboards alongside it. So you have a discover, visualize, dashboard, canvas, maps, well, a lot of applications. The one that we're going to be looking at the most, at least on this tutorial, is on the discover one. Okay, this is where the magic happens. Since there's no data, okay, it's going to say, hey, I couldn't find any Elasticsearch data because, well, we haven't pushed any to it. So let's start with that. Okay. Now we need to set up the Logstash configuration pipeline to accept the syslog data and send it over to Elasticsearch. The Logstash pipeline configuration has three main sections: input, filter, and output. Let me show you with an example. This is the first version of the configuration that we're going to insert. So the input is where the listeners, protocols, ports are set up to for Logstash to ingest data. The filter section, which is, well, not here, not shown here yet, is mainly used to manipulate and parse the data. And finally, the output section instructs where to send that resulting events. Okay, So, for example, in this case, we're listening on protocol UDP, and the port is going to be 5014, and we're to add a type field, just specifying that the data is going to be syslog type. The output is going to be, well, Elasticsearch. This is the endpoint, and this is the index where the documents are going to be stored. It's in a date format, and it's going to be prepended with the net Logstash string. Okay. Now we just need to copy this and apply that right into the Logstash configuration file. One thing to note here is that you can connect to the bash console of the container using the auxiliary console. So that is pretty handy, and kudos to the GNS3 to integrate that capability. So, and actually have one already here. Yeah, so here's the Logstash info. Okay, and the default configuration is stored here. Yeah, and this is the default setting. So by default, it's going to use the bits, which is another Elastic product on port 5044, and the output is going to be codec Ruby debug. Okay, we're going to well, basically we're going to replace this configuration with this one. Okay, with our syslog information. I'm going to write it, and yeah, I should be seeing changes on the pipeline. Okay, great. It reloaded the pipeline, and great. Started listening on UDP 5014 on all the addresses. So that's really good. Okay, there's some changes also here on Elasticsearch saying that there's some Logstash configuration by default. Okay, seems to be pretty good. Now let's start generating some data, right? Okay, so we're already here. And for us to start generating some data, let's shut down one of the interfaces. Of course, not the 001, which is the management interface. Let's shut down one of the OSPF ones, so 01 if I'm not mistaken. OSPF. Oh, come on. Yeah, 01 is one. Okay, so this is the neighborship with 10113. Say shut. Okay, this should send a lot of data, and actually I should. Oh, since I'm on SSH, I shouldn't be seeing any kind of messages here yet. But well, it should be sending a lot of syslog events, and let's unshut it. Okay, and also I'm going to get out of the configuration mode. Great. Nice. There's some changes here on Elasticsearch. Let's take a look at it. Right. So actually here on the logs I can see something already happening. So it managed to create the index. Okay. And we're ready to go. Let's look at that on the Kibana side of things. Okay. Actually, I'm going to refresh the entire app. And I'm going to check here on the index patterns, which is, well, if I go to discovery pane, since there's no index patterns, it's going to redirect me into the management index patterns page. Now it sees some data already here, so that's pretty good. Let's create an index pattern. Now, what are the index patterns? Well, this is basically a way for Kibana to parse the information that is stored in Elasticsearch and get the information from the values in the fields and their types, so it can create proper visualizations from them, from the stored documents. Okay, let's continue. So yeah, we hit the next step over here. We need to specify which is going to be like the timestamp field. By default, all the events that are generated from syslog events, or well, that are parsed through Logstash, is going to add the timestamp when you receive the event. So I'm going to use that same field. okay? And I'm going to create the index pattern. Great. So by default, you see these fields are going to be like internal fields. So timestamp, version, some keyword, ID, index, score, source type. Okay, so all these are internal fields of the Elastic Stack. Okay, these are the ones that we are configured inside the events. Since the type is syslog, it gets the host field. Okay, and there are a couple more. The other one is message, and the other one is type. Okay, but this is like the schema representation and the information of the fields. Let's take a look at the data. So yeah, here we go. Here's the data. Let's open one document. Over here we can see the events. This is one of the documents, and which is one of the syslog events. We can see here, oh yeah, we can see that this is a message when OSPF changed the adjacency of the interface from loading to full, okay? And this is stored in the message field, okay? So by default, everything, all the raw syslog data is inside the message field. The host is who actually sent that information. And here's the type syslog that you saw earlier on the configuration file, okay? You can see the JSON representation over here as well. If I put here to add, I can see like a table view of the events and the messages. So I can see information from OSPF. I can see information from the sysconfig, the parser, the links, and all that. Now let's jump up the game. Okay. Okay, we're going to apply a new Logstash configuration, right? And for that, I'm going to introduce the filter section. The filter section is used to manipulate and transform the data, and it has many functions. The one that we're going to use is the grok one. This is going to be the main character to transform our syslog events into structured data. Now, the grok function tries to match the data with a regex pattern. It is usually called a grok pattern and saves the extracted data into a named field. So for example, in this case, I'm saving the syslog pre, I'm saving the into device, the log date, and so on. And these are the grok patterns. Okay. Logstash by default has some built-in grok patterns, and I'm going to publish also the link for the grok patterns alongside this video. But you should know that there are some really good grok patterns out there that should fit most of the use cases. Okay, and there are some made by Cisco as well, and are really handy because in this case it's easier for us to parse the syslog data from the iOS V routers. Now, if there's no match, if there is no match, then it will add a grok parse failure tag into the document, to the JSON document. Okay, and this is key because we want to further improve the parsing of our logs, and we should search every now and then for grok parse failure inside the tag field to basically do some trial and error, improve them more and more. I also added the iOS parse tag into the event for further processing, and you're going to see this in action in the full-blown configuration pipeline for this demo. Okay. The syslog pre. Okay, the syslog pre. Actually, I'm going to show you what the syslog pre value is, but basically, based on the RFC, the pre number, you can decode the pre number from a syslog event and get information about the syslog facility and the severity of that event. Okay, so this is actually extracted from this field, and this function over here just decodes that value and adds those fields into the document, into the JSON document that is going to be sent to Elasticsearch. Okay, so great. Now, before applying the configuration into the Logstash pipeline, we can test it on the Kibana grok debugger. Let's see that in action. Okay, so Let's take a look at one of the messages right here. Yeah, let's grab this one. And let's go to the debugger. I'm going to the DevTools, and you will see here the grok debugger tab. And you can see that we have some sample data to insert, the grok pattern to insert, and how to and then to simulate it. Let me paste the sample data, and let me copy the grok pattern. Okay, great. Let's simulate it. Nice. So what does this mean? This is the pre-number, this is the device, this is the log data, these are the vendor facility and then vendor facility process, okay? Some OSPF information, well, and this, after this, is the log message, okay? All of this is being parsed here with this grok pattern, okay? Which is some a mixture of the grok pattern that I told you about, which has regex patterns and some regex expression as well. Well, that's basically it. Okay, we're going to use this as our general section. Now let's apply the configuration. Okay. Okay, the pipeline has been restarted. Okay, and the UDP listener is listening again. Now let's start generating some data. Let's see if the grok pattern is working as expected. Let's do the same thing again. Going to interface gigabit 01, going to shut, and also unshut the interface. And I'm going to exit the config mode. Right. Now, before actually going to the discovery pane, since this is going to introduce some new fields, I need to go back to the index patterns and refresh the field list. Okay, this is needed for Kibana to identify the new fields and the values and the types that they're gonna have. Okay, so yeah, you see the number increase and we have more fields over here, so that's good. So a good indicator. Oh yeah, so we have here, let's open one of the grant. So this is the document per se. We have the message field, which is actually redundant at this point. We might put a Logstash configuration to delete this field so we don't have duplicate data. We have the log message over here. We have the syslog pre, and this is the one that I told you about that is decoded, and it's going to give us the facility code, and the severity code. I have the tags here, the vendor facility, and the vendor facility process. Now, with this information, now at this stage, I can actually create a proper log view of the data. Let's do that. I want to first show me the device name. Next, the syslog severity. Okay. Then I'm going to put the vendor facility, then the vendor facility process, so to identify who is who, and the log message at the end. Okay. Nice. Let me save this. Okay, so now we have a log view that tells us which is the device, and we can actually filter. So for example, I have some IOSB 3 here, and I have IOSB 1 over here, and I have OSPF information. Let's say that I want IOSB 3 only information. I can filter here based on this value, and here's the OSPF information. Okay, nice. I can also filter based on only the error. Okay. You can also do a lot of the of operations inside the left pane over here. For example, if you click one of these, you should see a summary of how many events based on the discover pane messages, how many messages are appearing in the discover pane. You can get a percentage of documents that have the notice or the error field inside on the syslog severity. Okay, so you can see that most of the messages are noticed once. Okay, that's pretty useful. Also for the device, you can see who's the device that is sending the most logs. So this actually gives you some really good and quick insights about the data, about your syslog data. Okay, and you can filter also based on these values. Okay, I think we're ready to now insert the full-blown configuration pipeline of this demo, which is the SCOF, this one. Let me open it a little bit more here to explain to you guys what it is and what it is doing. So the new part here are these three sections over here. Okay, so after the syslog event is generally parsed, we verify that the event was actually parsed, and also we start looking at information like the vendor facility and the vendor facility process. So I have here a section, a conditional, that if it's parsed and the vendor facility is parser, I'm going to try to get the username and the command that was issued. This is for the config audit view. Okay, if there was an issue on the machine, I want to also add, well, besides the grok parse failure, I want to also add this tag, config audit parse failure. Okay, that way it's easier for me to know where the issue is when parsing the document. The same thing I'm doing on the interface status. So in this case, if I see a line protocol and an opt-down message facility process, I'm going to get the interface and the interface state. Okay, and for the OSPF adjacency changes, the same thing. So I'm going to take a look on the OSPF vendor facility and adjacency change vendor facility process, and yeah, and I'm gonna get a lot of information on this guy. I'm gonna get the OSPF instance, the neighbor, the interface, the before state, the after state, and what was the action result. Okay, so let's continue. I'm going to copy and paste this. Okay, just save this. Okay, the pipeline has been restarted. Right. Actually, let me see here one thing. Let me see if I can. Okay. Shut and unshut. Try to see if I can get some OSPF messages of iOS v2 as well. Okay, this should do the trick. Now let's go back to Elasticsearch. Okay, so I'm seeing information over here, and I see information from iOS v2 as well. Nice. And here it is. I have some more fields. In this case, since this is an OSPF event, I have the after OSPF state, the before, and all the OSPF information from the syslog event. Okay, if I look at something like the parser, okay, let's take a look here if I'm not mistaken. Yeah, I have the command use and the username. Okay, we need to also go to index patterns and refresh the field list. That's really good. Okay, so let's create the network config audit view that I was telling you about earlier. For that, I'm going to click new. Okay, and I'm going to select the following fields. Device, that's the first one. Okay, the next one is going to be username. Great. and the next one is going to be command used. Great. Now there's a lot of events here that are not, well, config events. So for that, I'm going to add a filter. I'm going to filter based on the facility process config log cmd. Okay. These guys over here, they have the same beta facility, but they were not parsed. Those are these events over here. But now you can see that on IOSB1, I connected to the router. I configured the interface, shutdown, on shutdown, and then I exit the config mode. Okay, so this is really good if you have some kind of devices that are handled by third parties, contractors, and you need to audit the configuration of the inserted devices every now and then. Okay, this is really useful. Yeah, so I'm going to save this. I'm going to save this as a config audit. Okay, so let's start with a visualization with a horizontal bar chart. Okay, let's create an horizontal bar chart based on the severity logs received. For that, I'm going to visualization. Okay, create new visualization, and I say horizontal bar chart. I need to specify the index pattern. This is going to be net Logstash. Here we are. Now, the metrics that we're going to use is the count. Yeah, this is going to be the metric count of the log messages that we are receiving. And the bucket is how we want to perform the aggregation of the data. Here will be the x-axis, the aggregation, and is going to be based on terms. Which is basically to divide the data based on the value of a field. And in this case, we're looking for syslog severity. Okay, syslog severity. Let's change the size as well to 8, so it can accommodate all the severity levels if they are present. And let's put the custom level to severity. Nice. Let's apply it. Oh, let's generate some data really quick. It's on the last 15 minutes. Okay, that's great. Of course, if I want more data, I can specify a longer time range. Okay, it's okay. And if we hover the pointer, we can see that we have around 10 messages with the severity set to notice, and only 2 with the severity set to error. Okay, that's great. Let's save this. I'm going to call this logs per severity. Thank you. Save the visualization. Great. Now let's create a pie chart that shows the amount of logs generated per device. Okay, we're going to do the same thing. We're going to click on in the visualizations menu. Oh, by the way, you can. This is a retractable menu, so you can see here this is the visualization menu. I'm going to create a new visualization pie chart. Where are you? Here you are. Net Logstash. Okay, great. Now for the pie chart, the metrics would be the same as before, the log count. Okay, so I'm just going to name it here log count. And the bucket will be aggregated based on terms, and in this case I'm going to split the sizes. Okay, so I'm going to take the terms aggregation, and I'm going to divided by the devices keyword. Okay, in this case I have 3 only devices, but in overall topology is 6, so I'm going to say just specify 10 in case I want to add another device. And I'm going to put the custom label as device. Okay, I'm going to apply that. We can see now the pie chart. Oh, this is a donut chart. Let's change that. Let's go to here. I don't want a donut shaped, and I want to show the labels. Right, this is better. So yeah, we have 30% of messages coming from iOS 2 and 70% of iOS 1 in the last 15 minutes. That's great. Okay, we're going to save this. As logs per device. Okay, that's pretty good. Okay, put the last 30 minutes. See, we can see I just changed the time picker to the last 30 minutes, so I can see information from iOS 3 as well. Okay, that's good. Now we have a pie chart that specifies the amount of messages that have that configuration. Now let's create a time series visualization of interfaces changes logs. Okay, this is going to be a little bit more complicated, and this is where the true power of Kibana comes into play. Okay, now let's go to the visualization. Let's go to create new visualization. Where are you? Yeah, TSVB. Okay. The visualization that we're going to create is one that allow us to contrast the amount of logs, the total number of logs, against logs that are interface changes and against logs that are OSPF changes. Okay, this could prove useful for troubleshooting scenarios. So I just want you to show you the capabilities of doing something like that. So first, I'm going to do the aggregation by count, because that's what we're going to do. We're going to count the events. But the group, we're going to group by filters. So the first filter, and what are filters? So filters are Kibana query language expressions, and you can look that up if you need some more introduction to them. But it's basically a query language that we're going to apply inside Kibana, and hence it's going to ask Elasticsearch for data that matches that filter. And I'm going to change the color here. I'm going to put this into orange. What I'm going to do is I need to know the interface state exists, okay, inside the log messages, and that well, actually this is more than enough. With this we should be good. And I'm going to label this one as interface status changes. Okay, these are the interface status changes. Grunt. Let me create another one. Now the second group, I'm going to put another color, let's say blue. And we're going to get OSPF after, for example, after OSPF state keyword exists. Okay. Actually, let me just specify something different. I want to see, so this is really good. Again, oh, sorry about that. Let me show you, because I want to show you the values. So with the Kibana query language, it is a really great tool, and you can see the values of the fields that are available. So for example, here we can see all the states that are on this field, on the after OSPF state. We want to see the inits, okay? So that way we can see when the neighbor is actually being initiated. Inits, and I'm going to call it like that, okay? And then I'm gonna add another one, which is the total logs. So on this one, I just need to verify that the log message keyword exists. Okay. So here we have this. We can see that these messages are, well, most of them are OSPF inits. And now we have, let's actually put maybe an hour the messages. We can see here some contrast of the log messages that we are receiving, which ones are interface status changes and which ones are OSPF inits, initialization. Okay, let me save this. I'm going to save this and I'm going to call it logs and user filters. Okay. Now let's create a data table of interface flaps per device. Okay. For that, we're going to visualizations. Let's create a new visualization, and let's go to data table. So we're going to create a data table of interface flaps per device. Okay, just to have a number, a quick overview of the numbers of flaps that we have on a device for a specific period of time. Okay. The metric will be count still, right? Yeah. But we're going to name this as event count. Okay. Now the buckets. Okay. So here we need to do two aggregations. First, we need to specify that we want to filter per device, and then we're going to specify we want to filter based on we're going to aggregate based on a filter, which is to verify that the interface state is present. Okay, so I'm going to split the rows. The aggregation is going to be, the first one is going to be terms, the field is going to be device, the size I'm just going to say 10, the custom label I'm going to say device. That's basically it. And I'm gonna add another bucket, which is going to be based on filters. The filters is that interface state keyword exists. Well, actually, I can say that if it's up or down. Let's just say up. Okay. Well, a flap is that it exists. So. Okay, and I'm going to label it. I'm going to say interface flaps. Okay. Run. So I can see that the interface flaps was an IOSB 1. Okay. IOSB 2 and IOSB 3 didn't have it. Okay. That's good to know. Okay, you have some more options here. So for example, if you have a really big table, you can create specify per how many items you want per page, and I'm going to show only 3. I don't need 10. And I'm going to save this. I'm going to say that this is interface flaps, and I'm going to confirm the save. Great. Now I'm going to create one last visualization, which is not a conventional one. This is normally used on dashboard controls. Okay, so you can quickly see and change between devices and syslog messages. Let me show you what that is about. So yeah, it's a control visualization. Okay, and you have like buttons. You can see this as a button inside your dashboard that you can apply and make some changes to look for data in a filter manner the way you want it. In this case, I'm going to create an option list for the devices that I'm going to use, and I'm going to create a severity slider, severity, range slider, to specify what kind of events we want to filter on the dashboard. Okay, so let me add an options list first. Okay, the control label is going to be devices. The index pattern is going to be Logstash, and the field is device. Okay, right. If I apply here, this is what you're gonna see, and here you can see the other options. So if I click USB, it's going to match based on this. Okay, so that's pretty good. Now I'm going to add a range slider. I'm going to say log severity level, this slider. I think this pattern is named Logstash, and the field is syslog severity code, the number. Okay, I'm going to apply the changes, and here you can see that the available values are from 3 to 5, which is the syslog events that we have from notice to error. Okay, let's save this. I'm going to save this as log dashboard control. Nice. Now let's create a dashboard, shall we? We just need to add all the visualizations that we created. So let's start with the dashboard control. Okay. Let's continue with the logs per device. Let's continue with the logs per severity. Let's continue then the user filters, the interface flaps, the config audit, and at the end we're gonna add the logs. Okay. Okay, so we have now let's rearrange this a little. So we have them. Okay, so we have a dashboard here. Let's test it. So if I say I want information from OSPF, let's apply the changes. Great. So you can see that the logs, all the visualizations change based on the dashboard console. So basically, we have everything from OSPF. These are the amount of messages that OSPF has sent. How many interface flaps? Only 2. These are the commands that were issued on OSPF, and this is the contrast of messages from the total logs against the interface status changes and the OSPF status changes. And you can see here the values. And here you just have the complete log of that device. Nice. Let's change that. Let's add more data. Okay. Actually, let's add more data. So I'm going to, well, I'm not gonna do, I don't need to. So apply the changes. Sorry, I was thinking of auto refreshing it. What I'm gonna do is generate more events. Yeah, let me start this. I'm going to shut down GNS3 2. Okay. Yeah, and we can see how, in a live manner, how the logs are changing, how the pie charts change, how the log severity changes, the time, how the users filters visualization changes. We see here OSPF commands also showing, and here the overall log messages. Let's save it. I'm going to say network logs dashboard. And here we are. We have a full-blown dashboard of the logs of our network lab of GNS3, and everything inside GNS3 and Dockers. So that's pretty cool. I don't like the white color too much. Just going to do something here really quick. Yeah, dark mode is, I like dark mode better. Dashboard. So I hope you enjoyed the video. This is a wrap for today. I will continue with more advanced configuration using Arista, and also pulling metrics out of the devices to create more meaningful dashboards. If you want to follow along, just ping me. I'll try to see if I can post a video about it or make a blog about it. And so okay, that's it. That's a wrap. Thank you, everyone.